Man-made materials. Learning objectives. Polymers. Synthetic clothing materials. Plastics. Environmental problems due to plastics. Recycling. In previous class you have read that fibers are of two main kinds, natural fibers and synthetic or man-made fibers. Natural fibers are obtained from plants and animals. In this chapter we will read about synthetic fibers or man-made materials. Man-made materials or synthetic fibers are made from complex chemical materials such as polymers, plastics, paints, cement, fertilizers, etc. Most of these chemical materials are made from raw materials such as crude oil, petroleum, natural gas, air, water, salt and limestone. We can change these raw material into fabrics through mechanical process or chemical reaction. All of these work is done in factories called industrial plants. Today, mostly people use synthetic fabric or man-made materials for their daily needs. Polymers. Polymers are macro-sized, large-sized molecules of relatively high molecular masses, which find extensive use in our daily life. They are obtained by joining together a large number of small molecules. The polymers, because of their giant molecular size, have a number of characteristic physical properties such as high tensile, pulling, strength, elasticity, ability to form fibers, etc. Polymers may be derived from either inorganic or organic molecules. Synthetic polymers are mainly derived from the organic compounds. Polymer molecules. Formation of polymers. Polymerization. The process of formation of polymers from their starting materials is called polymerization. Monomers. These are the small molecules that combine with each other to form a polymer. Classification of polymers. Polymers are mainly classified in two ways. A. Classification based on source or synthesis. B. Classification based on molecular forces among its atoms or structure. A. Classification based on source or synthesis. Depending upon the sources from which they are obtained, polymers are broadly divided into two classes. Natural polymers. Polymers which are found in nature, i.e., in animals and plants, are called natural polymers. Starch, cellulose, proteins, nucleic acid and natural rubber are its examples. Natural polymers. Synthetic polymers. Natural polymers are not always satisfactory for all purposes. Moreover, natural fibers like cotton, wool, silk etc. cannot meet the even-increasing clothing need of the mankind. All those needs led the man to synthesize polymers in the laboratory and factories. These man-made polymers are called synthetic polymers. Some important synthetic polymers are polyethylene, polystyrene, polyvinyl chloride, PVC, bakelite, nylon, Dacron etc. B. Classification based on molecular forces among its atoms or structure. Depending upon the magnitude of the intermolecular forces, polymers are divided into four categories. Elastomers, polymers in which the intermolecular forces of attraction between the polymer chains are the weakest are called elastomers. They have the ability to stretch out over 10 times their normal length and return to normal length when forces are withdrawn. Natural rubber is the most important example of elastomers. Other examples are vulcanized rubber, Bunais or SBR, and styrene. Fibers, polymers in which the intermolecular forces of attraction are the strongest are called fibers. They have high tensile strength and least elasticity. They have high melting points and low solubility. The fibers are used in making sports goods and are also used in spacecrafts. Thermoplastics, polymers in which the intermolecular forces of attraction are in between those of elastomers and fibers are called thermoplastics. These are linear polymers which are hard at room temperature, become soft on heating and again rigid on cooling. These polymers can be molded into toys, heads, buckets, telephone and television cases, etc. Some other common examples are polythene, polypropylene, polystyrene, polyvinyl chloride, PVC, AON, etc. Thermosetting polymers. These are semi-fluid substances with low molecular weights, which, on heating, undergo change in chemical composition to give a hard, infusible and insoluble mass. These polymers can be melted only once when it permanently sets into a solid. Some examples are phenol formaldehyde, bakelite, urea formaldehyde, melamine formaldehyde, etc. Thermoplastics made toys. Polymers in daily use. Polymers are of great use to man. Plastics are used almost everywhere and in every industrial activity. Some of the polymers used are as follows. Low-density polythene. It is manufactured by heating ethylene to 473 K under a pressure of 1500 atmosphere and a presence of traces of oxygen. It is used as a packaging material in the form of thin plastic films and bags. It is also used as insulation in electrical wires and cables. Polythene-made bags. High-density polythene. It is prepared by coordination polymerization of ethylene. It is a translucent polymer and has greater toughness, hardness and tensile strength. It is used in the manufacture of containers such as buckets, tubes, housewares, pipes, bottles and toys, etc. Polypropylene or polypropene. It is a harder and stronger polymer than polythene. It is used for packing of textiles and foods, for making linears for bags and heat-shrinkable wraps for records and other articles. It is also used for making automotive moldings, seat covers, carpet fibers, ropes, etc., and in the manufacture of stronger pipes and bottles. Polythene-made tubes. Polystyrene or styrone. It is a good transparent polymer. It is used for making plastic toys, household wares, toys, combs, household articles, hot drink cups, telephone, television and radio bodies, refrigerator linings, etc. Polypropylene-made seat. Palladianus. Synthetic rubber such as neoprene and bunias are polymers of this class. Neoprene is an excellent rubber-like material and is used in the manufacture of hoses, shoe heels, stoppers, etc. Bunias is used in the manufacture of tire, rubber soles, waterproof shoes, etc. Polystyrene-made telephone. Polyacrylates. These are commercially known as plexiglass, lucite, acrylite, and perspex. The most important property of these polymers is their clearness and excellent light transmission, even better than that of glass. These are used in the manufacture of lenses, light covers, light shades, signboards, transparent domes and skylights, aircraft windows, protective coatings, dentures and plastic jewelry. Palladianus-made rubber soap. Synthetic clothing materials. In order to meet the growing needs of increasing population, synthetic clothing materials are very widely used. Synthetic fibers was invented in 1884 and was named rayon. These fibers were first developed as substitutes for rare and costly natural fibers. Rayon was followed by nylon, a silk substitute made from coal, air and water. Common synthetic fibers include rayon. This is man-made silk which consists of purified cellulose in the form of long fibers. Rayon fiber is chemically identical to cotton but has a shine like silk and is hence called artificial silk. It is used in India on a large scale for making textiles, tire cord, carpets and surgical dressings. Rayon-made carpets. Nylon. It is a joint venture of American and English scientists. Hence the name nylon represents the names of American and British cities New York, and London, London. It is made by condensation, polymerization of smaller organic molecules not found naturally. Nylon is the first synthetic fiber made by man. It was first made in 1939 as stockings for women. Today nylon is used besides fabrics for a variety of purposes, such as fishing nets, ropes, parachutes fabrics, and type cord. It is also used for making machine parts. Nylon 66. It is made by condensation polymerization of hexamethylene diamine and adipic acid. It is used in making brushes, synthetic fibers, parachute fiber, ropes and carpets. Nylon 6. It is made by self-condensation of a large number of moles of aminocaproic acid. Nylons are insoluble in common solvents, have good strength and absorb little moisture. These are mainly used to make fibers for manufacturing garments, carpets, ropes and tires etc. Polyesters. Dacron is the best known form of the polyesters. It is manufactured from methylene glycol and terephthalic acid. It is also called terylene. It is a crease-resistant fabric and has low moisture absorption. It has high tensile strength. It is used for making wash and wear clothes. It is blended with wool to produce better crease and wrinkle-resistant garments. Polyester-made clothes. Plastics. Plastics are synthetic polymers which can easily be molded or set into a desired shape. Examples of plastics are polyamide, polyesters, polythene, bakelite, terylene, melamine etc. A variety of plastics have been made by replacing one or more hydrogen atoms in ethane and polymerizing the resulting monomer. Types of plastics. Plastics are of two types, thermoplastics and thermosetting plastics. You have already read about these types while studying polymers. Here we shall know about various types of plastics and their uses. Bakelite. Bakelite, a hard plastic, was invented by an American chemist Leo Hendrik Baekeland. He found that mixture of phenol and formaldehyde formed a sticky mass when mixed together and heated. Bakelite was originally used for electrical and mechanical parts. It is the first true plastic, and also the first thermoset plastic. It cannot be molded again. It is cheap, strong and durable. Uses. Bakelite is molded into thousands of forms, such as radios, clocks, televisions, telephones and billiard balls etc. Bakelite-made object. PVC, polyvinyl chloride. After the First World War, improvements in chemical technology led to the invention of new plastic forms. PVC in its normal form is stiff, strong and heat and weather resistant. There are hundreds of uses of PVC. It is used for making plumbing gutters, house sidings, enclosures for computers and other electronics gear. Today PVC is used to manufacture furniture, portable kitchens, water tanks, huts, doors, windows, partitions, paneling of walls, automobile parts, stationery items, utensils and many more things. PVC pipes. Polystyrene. It is a rigid, brittle, cheap plastic that has been used to make plastic model kits etc. Uses. Currently polystyrene and its forms are used in toy manufacturing and other novelties. Polystyrene-made toys. Synthetic rubber. Synthetic rubber is another form of plastics which has proved very useful to mankind. It is used in fuel hoses and as an insulating material in machinery. Synthetic rubbers play an important role in the space race and nuclear arms race. Sci-facts. The first synthetic rubber polymer was obtained by Lebedev in 1910. The first synthetic rubber introduced in 1930 was neoprene. Melamine. Melamine is a hard plastic. This is used in making the cooking items like cups and saucers, as they do not break on dropping down. Bubble gum contains synthetic melamine, known as butadiene rubber. Melamine-made object. Biodegradable plastics. Research has been done on biodegradable plastics that break down with exposure to sunlight. Starch can be mixed to plastics to allow them to degrade more easily, but it still does not lead to complete breakdown of plastics. Some researchers have actually genetically engineered bacteria that synthesize completely biodegradable plastics, but this material is very expensive at present. Recently, however, a new type of biodegradable resin has been introduced in the USA. It is called plastarch material, PSM. Environmental problems due to plastics. By far the largest use of synthetic polymers is as plastics. A major portion of it is used as throwaway containers and packing materials. Since plastics do not degrade by themselves, they are non-degradable. Over a period of time, this durability poses great threat to the environment. It also creates great waste disposal problems. With the ever-increasing use of plastics and other polymer products, soon the entire civilization will be buried under a pile of plastic debris. Burning plastic can release toxic fumes. Also, the manufacture of plastics often creates large quantities of chemical pollutants. Plastic pollution is when plastic has gathered in an area and has begun to negatively impact the natural environment and create problems for plants, wildlife and even human population. Often this includes killing plant life and posing dangers to local animals. Plastic is an incredibly useful material, but it is also made from toxic compounds known to cause illness, and because it is meant for durability, it is not biodegradable. The waste plastic articles keep on accumulating in the surroundings and pollute the environment. Thus, plastics are not environment friendly. The waste plastic articles, like polythene bags, etc., thrown here and there carelessly get into dirty water drains and sewers, and clog them. This makes the dirty drain water, or sewer water, to flow over the streets and roads, causing unhygienic conditions for the society. Plastic environmental pollution. Recycling. By the 1990s, plastic recycling programs were common in United States and elsewhere. Thermoplastics can be remelted and reused. Unfortunately, recycling plastics proves difficult. The largest problem with plastic recycling is that it is difficult to automate the sorting of plastic waste, so it is very labor-intensive. Moreover, recycling sometimes can be unprofitable as well. What plastics are not accepted? No plastic bags. Plastic bags are by far the worst contaminant in the recycling bin. Please do not put plastic bags in your bin, and please do not bag any materials. No foam. White foam cups and containers are not a recyclable plastic. These products can be easily avoided for their safer, reusable or recyclable counterparts. Activity 3.1. To show the water-absorbing capacity of fibers. Soak 10 grams each of cotton, wool, rayon, silk and nylon fiber samples in water. Allow these samples to drip the water. When dripping stops, weigh each of these soaked samples separately. What will you observe? Each sample will show an increase in weight. This increase in weight is not uniform but varying. This shows the relative water-absorbing capacity of different fibers. Water-absorbing capacity of fibers. Activity 3.2. To show the tensile strengths of fibers. Take a small metallic or plastic pot with a long round handle. Select some steel balls of same weight. Take 1-foot-long threads of cotton, wool, nylon and silk. Tie one end of the fiber thread with a nail in the wall and tie another end of the thread with the handle of the pot, so that the pot hangs with the help of the thread. Now put the steel balls into the pot one by one. Keep the steel balls putting in the pot till the thread breaks. Count the number of balls that cause the thread to break in each case. What do you observe? Each thread needs different number of balls to break. This shows that different fibers have different tensile strengths. Tensile strength of fibers. Activity 3.3. To show the effect of flame on different fibers. Take pieces of equal lengths of different fibers like cotton, wool, silk, acrylic, nylon, polyester etc. Light a spirit lamp and keep a china dish near the lamp. Hold a fiber sample with the help of a fire tongue and put it over the flame so that the fiber catches fire. Now put the burning piece of fiber into the china dish and make observations with respect of different fibers. You will experience the following observations. Cotton, it burns with a yellow flame, light smoke and glowing embers. It does not melt and does not draw away from flames. It smells like burning leaves. Wool, the flame of cotton is steady. Burning wool smells like burning hair. Silk, it burns readily and smells like burning hair. Ash is easily crumbled. Acrylic, burns readily. The smell is harsh or acrid. Nylon, burns slowly and melts. It pulls away from flame. Smells like burning plastic. Rayon, burns rapidly and leaves a light ash. Smell is close to burning leaves. Polyester, melts and burns at the same time. Smoke is black with a sweetish smell. Keywords. Monomers. Small molecules that combine to form a polymer. Polymer. Macro-sized molecules of high molecular masses. Polymerization. Method of making polymers by combining monomers. Rayon. Artificial silk, synthetic clothing material. Nylon. Artificial cloth material made by condensation polymerization. Polyester. Polymer clothing materials. Plastics. Synthetic materials molded in desired shapes. PVC. Polyvinyl chloride, a material used for making tubes, pipes or furniture. Summary. Polymers are macro-sized useful molecules of relatively high molecular masses made of some repetitive units of molecules. Polymers are derived from either inorganic or organic molecules. Polymers are classified based on source, structure, synthesis and molecular forces. Polymers can be natural or synthetic. Polymerization means making polymers from the monomers. Polymers can be elastomers, fibers, thermoplastics and thermosetting. Rayons, nylons, polyesters are the polymers that are used in synthetic clothing. High-density polymers are polythene, polypropylene, styrenes etc. Plastics are synthetic polymers which can be easily molded or set into desired shapes. Bakelites are used in making electric items and mechanical parts. PVC has a large variety of uses, from toy manufacturing to utensils. Plastics cause environmental problems. They do not disintegrate by themselves. Recycling of plastics is difficult. Some biodegradable plastics disintegrate with sunlight.